Okay, friends, I am pretty sick, so there's going to be a little sniffling and coughing going on in this video. But I still know math, so let's do this. This is 2-6, scatter plot and best fit lines, and the reason this is in here is we know how to find the equation of a line. You've done best fit lines, I would imagine, in science over the years, where you find a line that kind of represents the data, even though the data is not necessarily in a perfectly straight line. So a positive correlation basically means that you have an increase over time. So as your x's go up on the number line or the x-axis, y's would go up as well. So you might have data that kind of trends upward like this. Doesn't have to be perfect because data is never perfect. So a line that would go through that would have a positive slope. Not surprisingly, negative correlation. Correlation is like how the data correlates. And so that's where that term comes from. Here, as your x increases and you move to the right on the x-axis, your y's go down, they decrease over time. And so you have a change that we would have recognized as negative slope in this chapter. Okay, so the correlation coefficient is denoted by R, just like slope is M and all the other letters that don't make sense. We used to do this on your graphic calculator and you would get an R value from your calculator. We aren't doing that anymore because not enough kids have them. But if you get into a higher math class where you do use that, you're going to find an R value on your calculator. And the value can range from -1 to +1. And ones are a perfect fit. So if I had data that was perfectly lined up and positive, my R would be a +1. If I had data that's perfectly lined up and negative, my R value would be -1. So positive and negative only indicates whether the data is going up or down. The closer you are to 1, the better the data fits the line. So like a 0 means the data is totally scattered and isn't really close to any line. So measure so it measures how well the line that you find, like the line of best fit, how close does that line actually fit the data? Is all the data close to it, or is it kind of spread out? So if R is near 1, the points lie close to the line with a positive slope, so it's going up. And if it's near -1, so like -0.8, -0.9, that means that the points are really close, but then it's coming down from left to right. So negative doesn't mean it's a bad correlation, it just means it's coming down from left to right. And if it's near 0, it basically means that the points are scattered. And they really can't be represented by a line going through that. So this is asking us to tell whether they have a positive, negative, or basically no correlation. We're estimating it to be one of these numbers. So perfect fit would be the 1 and -1. No correlation at all would be 0. And something kind of in betweenish would be the 0.5s. So if I'm looking at the dots in this first one, I would say that the line of best fit kind of goes through the middle, because then I have some dots above, I have some dots below. It's certainly not perfect, but it's sort of trending upward. So it's definitely positive in its slope, but I would only give this a 0.5 because the points are not really that close to the line. So if my only choices are 1 or 0.5, I'm going to go 0.5. And it's not 0, they're not completely scattered. In this second example, I can see that these are a lot closer to the line, and some of them actually just land right on a line of best fit. So that would be a negative. And since I don't have any choices close to -1 but not right at it, I'd go with -1. Even though -1 typically means every single point is on there, we don't have any options of like 0.75 or -0.8, so we're going to pick the best of the options they gave us. It's a better fit than a 0.5. Sorry. And then in the last example, I don't even know where to draw a line. Like, does it go here? Does it go here? Here? So there really isn't a correlation. And so I'd have to say there is none, and I'd give it an R value of 0 because there's not a trend. It's not trending upward. It's not trending downward. It's just scattered. So that's just the concept of R. And then the other thing is we're going to try to figure out like when is it positive, when is it negative, and then be able to find a best fit line. So tell whether the scenario is positive, negative, or no correlation. The first one is time spent on the treadmill. So like I would call that X and think as the time I spend on the treadmill goes up, the number of calories I burn would also go up. And since they both go up, then that's going to be positive. The number of days you are at school and your GPA, I honestly don't know how I feel about that one. I think the intention is that the more you are at school, your GPA is higher, and that's typically what happens. But I don't think that's always what happens. I certainly have some students who end up missing a lot of school and do really well. But I think the intention here is for us to say, hey, if you go to school more, you will end up with better grades because you obviously are hearing the material and able to do what you're doing. So I'm going to go ahead and give it a positive. Excuse me. So here we're talking about your height as an X and the number of siblings you have as a Y. There's no correlation. Like as you get taller, you don't necessarily have more siblings or less siblings. So there really is no correlation here. Those are two unrelated variables. The number of people eating a pizza, so that's my X. As the number of people increases, how much you get would go down because now you're sharing with more people. So since they're going opposite directions, that's going to be a negative trending line. So that's just conceptualizing when is the relationship positive or negative. Okay, so let's do our best then here to plot some data and then find an equation of the line. So we're supposed to find an equation, approximate the best fit line, and then we're going to use our equation to predict the number of alternative fuel vehicles. I should read it to you. The table shows the number Y in thousands. So these are in thousands. Like here where it says 280, it really means 280,000 of alternative fueled vehicles in the U.S. X years after 1997. So 0 here means 1997, 1998, and so on. So we're going to go ahead and label this. This is going to be years after 1997, and we have data for 1 through 7. So I'm going to have 1, 2, 3, 4, 5, 6, 7. And then up the side is my Y, and that's going to be the number of alternative fueled cars. And that's going to be in thousands. So you want to make sure that the general public knows that. And my smallest number is 280 and my biggest number is 565. So I'm going to go like every other one, cut by 50s. So this will be 200, 300, 400, and so on. And that way I'll get to 600 at the top. I'm sure you can see that really well because I did a great job of making that neat. Anyway, 0 to 80. I'm going to just kind of do the best that I can here. 1 to 95. 2, 322. And I'm just going to go through and plot my points. At 3, I'm up to 395. Then I'm at 425. 471. 534. So here's 5, here's 550. So 534 would be up here-ish. And then 565 would be over here-ish. So that's kind of my data points. So like if you collect data in a science class, then you end up with data points. So you end up trying to find a line, just kind of using a straight edge that's going to go through some of the points. And so this is, to me, a good fit line because it goes through some. There's a couple above, there's a couple below. And then to find the line, I'm going to do what we've been doing in class and just say, I'm going to use this one here. And then Actually, I'll use this one only because then it will match the online notes. So if you're doing the online notes, you can see that. And then this point here. So keep in mind that I'm going to use those data points to kind of estimate like a slope and my intercept and such. So the 2 points I'm using are my 395, and 534. So if I go to estimate my slope, I'll have 534 minus 395, just y2 minus y1 over 6 minus 3. Turns into 139 over 3, which is 46.3 repeating. So I'm going to go ahead. I don't know that all the teachers have been doing it this way, but I'm going to go ahead and use my point slope where I can just plug in the values that I know. I have to pick a point, so I'll probably choose this one, just slightly smaller numbers, and then I have to use my slope. So I'll have y minus the y value of the point that I chose equals the slope times x minus the x value that I chose. And then there's always 2 steps from there. One is to distribute this. And then to add or subtract if needed this number over. So my best fit line, like the line that comes pretty darn close to representing this data, is going to be this. And when they say later, use your equation to predict the number of alternative fueled vehicles in 2015, first I have to figure out 2015 is how many years after 1997, because that's what it told me to do. You know, that's what they're graphing. And so that's going to turn into 18. And then I'm just going to plug that in for my x, because x is that time. And when I do that, I'm ending up with 1089. But keep in mind that that's 1,000, because it was in thousands. So if you want to, you could just add the extra zeros and have it be a million. But however you'd like to represent it. And then that's just going to be alternate fueled cars. So those are the concepts for 2-6. Keep in mind you can make a note card for this upcoming test. So anything you don't feel confident about doing or remembering, you can just create a note card for yourself and use that. Hope this helps.